All right, here we go. Hey everyone, I'm Pulse, your glowing blue co host, and welcome to today's deep dive into LLM diffusion. First off, thanks for joining us again. Hope you enjoyed our first episode, even with those little audio hiccups we had. Today, we're diving into some really cool topics. We'll start with what diffusion actually is, then we'll look at how diffusion works in image models. After that, we'll dive into the newest frontier, diffusion in large language models. We'll also give you a sneak peek at a Gemini diffusion demo. And finally, we'll check out a local image diffusion demo running on a GTX 3080. So sit back, relax, and enjoy the clip.
We'll do a deep dive, and the topic today is diffusion models. And it is truly mind-blowing. We do have special access to Gemini diffusion, which we'll play around with today. But first, it's always good to understand what diffusion is, how it works, and why it's important. You guys may or may not know what diffusion is. This is actually how images get generated. So how does image generation work? It's actually not an LLM. It's not a language model, right? It's a different approach for images. And we'll get to how this is just basically a background on diffusion so that we can experience the diffusion language models better. So how does it work, basically? So you've experienced the magic. Perhaps you have not, actually. So let's do a new chat here with ChatGPT. Generate an image of the Kitchener Ion train riding through King Street in Waterloo. Well, let's see what happens, right? So generating images have always been mind-blowing, even when it was early. And it's not exactly using the same AI that generates the text, right? It's completely separate. So OpenAI, I think it was, I'm going to say 2 months ago, they released an incredible version of it. And the difference here from others is that it plans the image first and then generates the image so that you can change the image without getting a brand new image. And I'll let you know why that's relevant soon. And if you haven't used image generators before, or you have in the past and had formed a poor opinion of it, they have gotten pretty good. Here's the one that I asked for. It's the Kitchener Ion train riding through King Street in Waterloo. And then I'm going to add some graffiti saying wetness protection wasn't here, just for fun. So, of course, graffiti is illegal, but you can see, and I have seen as well on Facebook, people arguing about all sorts of political matters, referencing a very obvious AI image as their ground truth, right? And you guys need to be really careful with that because pictures now, AI-generated images, decreasingly so, are looking very real. So it's very difficult to discern from one another. One of the many threats of abuse, arrest. If you haven't played around with ChatGPT 4.0 image, get the free version, ChatGPT. You can turn on privacy, or at least turn off use my data in the settings. That should give you at least some peace of mind. And on a free plan, you get about 2 to 3 image generations per day. Nevertheless, it's really good experience to kind of figure it out, or at least get used to this sort of content creation, as well as advanced voice, but we'll cover that some other time. All right, fantastic. So this is diffusion, taking text and generating an image. At this point, it's really good. 6 months ago, it was laughable, but still really good. But people like to laugh about it because it wasn't perfect. Still isn't perfect. So here's an example. I generated this image in the same way to convey my message. Okay, so how diffusion works is that it starts with noise behind the scenes. And I always liken it to squinting, right? When you squint at something, you can't really make it out, but you can. And as you open your eyes, everything comes into focus. And then once your eyes are fully open, you can see things very sharply. That's how it works. It starts with random noise, and then it starts creating an outline of some things that might be there, but it's not sure what yet. Then it does it again in another phase or another pass, and unsquints a little bit more to make it clear, add some detail. It takes as many as you ask. when you build a system like this, or at least use this to deploy a system like this. But this is how it works. From grainy image to a clear image. So that's how the diffusion or the inference part, how do they build something like that? Is it magic? Does this cat live in the computer? No. So basically, it's reversed. It starts with the image, and then it adds noise, and that's how it trains it. So basically, it takes billions, perhaps not trillions, but billions of images, and it takes the influence of what that image is and the description of the image. Then it starts adding random noise to the image backwards and trains that, oh, a cat with a bunch of random noise, or it's a far more detailed explanation than a cat. So like an illustration of a cat with a dark outline looking at the camera with some noise added looks like this. Then it repeats it. The same description with more noise added looks like this. And then the same description with all the noise added looks like this. So that's how it trains it. It trains it with the image, adds noise, so that when it actually goes the other way, the component compares the training of the noise version of the image with the description, and then removes noise slowly, and the most likely arrangement of pixels come into place. So that's how diffusion works. So just to recap how images are generated, it's basically squinting at a lot of noise, it's squinting a little bit, adding detail, doing it again, doing it again, doing it again, until the image is very clear. And that's why early images or early image generators would have broken fingers or multiple arms or things that look very odd. It's because that at some stage of the squinting process, it had thought it saw multiple fingers or multiple arms, and as it unsquinted, there was no going back. Those arms exist right there. Things have improved. They can go back and forth and correct things, and that's basically reinforcement learning after the training. Okay, so I wanted to demonstrate this with text because Google Gemini, they've also announced this on their Google I/O, where instead of an LLM running its mouth and predicting the next word, this is a non-reasoning model, it will squint at random letters and then unsquint until the answer appears. And apparently this is 5 times faster and accurate to the level that they're at. This is not like the best AI that's out there, but the message here is that there are other ways of chat completion other than a transformer model where you're just predicting the next word. And this is just mind-blowing for me. And last week we did get access to Gemini Diffusion to sample it out. And I kind of want to show it. So the first thing I'm going to do is I wanted to make a little illustration like this to demonstrate the same thing, but using text. I couldn't find anything. I couldn't even generate passages to demonstrate it. It would take me a long time to replace letters with characters. So what did I do? Something that everyone should think about doing whenever they're trying to solve something. Let's just build a tool. And building a tool is just as easy as doing the research. And this is the new paradigm of software, right? Instead of looking for a solution, you just ask for the solution and you get it. So I've written this prompt using meta prompting, meaning I went back and forth until the result I liked is good. And then I asked for a prompt template to get that result so that I may use it in this presentation, or some people keep it in their template library or anything like that. So I think the first thing I should do is just do it in Gemini first. Okay, so here we have a Gemini 2.5 Flash, which is also mind-boggling in its own way on how inexpensive it is and how quick and good the results are. And the first thing I'll do is read the prompt. So, create a responsive web app tool that allows users to add varying amounts of noise to a passage of text. The app should include an input box text for the original passage, and then I said pre-filled with a 100-word passage about Kitchener-Waterloo, Ontario, a slider named noise level ranging 0 to 9. 0, no characters replaced. 9, random characters. And then an output display box showing what I'm trying to demonstrate here at a very basic level. And these are just requirements for itself. Okay. So this is Gemini 2.5 Flash. This is a sort of LLM model that we all are familiar with or going to be soon. And it's basically going to now build that tool for me with code almost instantly. How many seconds did this take? It didn't say. Probably 7 or so, I think. Anyways, here's the tool. We've got the original passage and the noised text. So similar to my attempt on demonstrating diffusion with images, I'm going to demonstrate diffusion with text in a way that isn't real, but it's an illustrative process on how the diffusion works, the forward diffusion and the reverse diffusion when training these systems. So here we add noise level 1. It's starting to add random characters all the way to the end. So this is a fully noised passage, similar to a fully noised image. And then we can just bring it back, and this would be like the inference part to the answer. And what's cool about this is not actually how it works. This is just me using Gemini to build a tool to show you how it works and to understand like how it works in behind the scenes. Okay. Next, I'm going to do the same thing, but I'm actually going to use diffusion to build it. That's meta, right? Inception. All right, let's go. And done. 2 seconds. 2 seconds, different model, whole different architecture, and was able to do the same thing 5 times faster. That's the statistic they are offering. 5 times faster of a inference type result using a diffusion methodology. Oh, it says right here, 1.7 seconds, 659 tokens per second, which is an incredible number. So we'll go into some more examples here, but what are the implications of this? First, just like the early stages of the internet, let's say dial-up came out, everyone's mind was blown at dial-up. Where we are today, 40 years later, 30 to 40 years later, dial-up is a joke, right? So a transformer architecture for chat completion in an LLM is laughable 20 years in the future, or even less, because we have AI to help us do these things now. So I always say, forming an opinion is very difficult to do now, because by the time you have the chance to express that opinion, things have changed and you're wrong. And it's moving forward all the time. So that's why we, as mind model, are kind of risk off as well, in that we don't want to wrap GPTs too much, because the shelf life of a solution like that is demonstrably limited. You want to keep things modular, composable AI, and always build it in a way that you can upgrade it very quickly. So this is Gemini Diffusion. Let's try some of the demos they want in here. They're suggesting in here. Please write a poem about AI and how it can help medical diagnostics in third world countries where doctors may not be as accessible. All right, let's see. It's going to diffuse a poem just like that, less than a second. Let's read it. In lands where doctors are scarce and far and healing seems a distant star, a digital dawn begins to break with AI's help, for goodness sake. No trains, no roads. I'm just trying to look for in remote villages far from town where specialist knowledge is unknown, a mobile device, a simple screen can bring insights sharp and clean. Great. So, we're fortunate enough to live in a first world where we do have access to medical services as a human right. That's not the case for many countries. So vision models and AI assistants, even though would not be a course of action here, is a lifesaver, truly, in other places. Okay, so that was just a poem. Under 1 second, pretty incredible, quite long too. Let's try trim planning here. I'm just clicking on these demos because they've been pre-vetted and this is still in beta. See what it does, asking for 3 different options for a 2-week trip to Peru. And in under 4 seconds, it gave, looks quite adequate. I'm not going to fact check these, But if you were to give more specifics or guidance, you can really have this conform to A, your actual trip, and B, the things that you want to see and prioritize accordingly. But the takeaway here is how quickly this happens, as well as how it's not using a traditional architecture, being transformers. Next one, let's try drawing. Make me a drawing app with multiple brushes and colors. 2 seconds. Draw here, quite simple, but the fact that this came to be out of nothing very quickly is impressive. Okay, for another one, I'd like to use the same example that I've used in the bootcamp at the Age AI event, or if we do AI bootcamps at your place of business, you've seen this one used as one of the first examples. And so you are a financial advisor. Please provide investment strategies for young adults in Canada. 1. Assess risk tolerance. 2. Suggest investment options. 3. Provide a sample portfolio. The goal is to create a beginner-friendly investment plan. Limit the plan to a monthly budget of $500. So let's see. Something anyone can use. 2.5 seconds. And it's basically assessing the risk tolerance, time horizon, comfort level with volatility, financial stability, suggesting investment options, low cost ETFs, tax advantage accounts, and a sample portfolio of an 80-20 allocation, stock ETFs, and bond ETFs. So, pretty risk off, but certainly good advice. What's toast? Okay. It's so fast. Oh, it's hallucinating here. I'm glad this happened. Unless it was asked to get in all the languages because it just had the time to do it. What? Okay, explain more. Okay, then translate into 10 other languages. All right, I thought it hallucinated, but it was actually just translating everything in 10 languages as well. Okie dokes. Okay, that's really fast. But I do want to try. Oh, okay. What is it building here? I think it's demonstrating k-means. This is a way of measuring the number of answers an LLM can choose from. But where is the... Okay, let's try xylophone. I'm quite... Oh. Okay, cool. If this ability is impressive, Gemini can do this already, like the non-diffusion models. It can write software like almost not instantaneously. A diffusion model like this, it looks like it can. 2 seconds. Okay, I was hoping for a tic-tac-toe game with a computer opponent. I didn't brush up my tic-tac-toe, but let's see if this works. All right, did I mess up? Oh, I won. Great. Okay, so basically this was the deep dive in diffusion. The biggest takeaway is not at how amazing it is, which it is. It's just that the AIs can get better of orders of magnitude by not even going through the typical transformer architecture that we are all enjoying today, right? So these things exist. There are many other ways of trying to solve a problem. And because of people already for many years in that research now being assisted with AI, it's becoming more of a reality than not, which is pretty exciting. Stability matrix using Comfy UI. So if you guys do have a graphics card of sorts, this is running a 3080 on a GTX 3080. You can see the stats at the top. Basically, it's using the computational power of that graphics card to generate the AI output. And this is called local inference or edge AI or anything that's closer to me as a person. This has great privacy benefits because nothing ever leaves the computer. But when we're dealing with open source models, there are no guardrails anymore. So if you do explore with Stability Matrix makes it easy, it is for adults, right? So here I'm just going monster truck, blue wheels, no driver. I'll do something else. Let's say hot air balloon through a telescope, maybe. Great. I'm going to demonstrate the steps that I mentioned earlier on like the squinting. I'm going to do one step. Let's see what happens. I think it's running. Let me check Comfy UI. So Comfy UI is basically another UI that is loading currently Stable Diffusion 3.5. Stability Matrix is a cool free program you can use to play around with the image diffusion models. You can download all sorts of open source models, which are all fantastic. You can train them if you'd like, but you can also play around with them. And nothing is as fast and as awesome as ChatGPT Image or other online cloud-based ones. Okay, so this is a single step for the hot air balloon through a telescope. It's terrible. Let's try 20 steps. And you can see how the squinting, you can actually see the squinting take place, the squinting, right? And the results are pretty good. Stable Diffusion 3.5, I think, is about, I'm going to say 6 months old, but I'm not sure about that. But the results are great. It looks like there's a spider or a crack on this telescope. You get a different image each time, and that's inherent, right? Character retention and prompt adherence are newer technologies that we're enjoying in 2025 that allow us to use train a model. Low-rank adaptation is an example of one's likeness to generate more images of the same person in the same environment, the same setting. This wasn't something that existed 6 months ago, and that's why running this locally don't really have those features. The more you ask from this GPU, the more hours and days it'll take to do anything. So cloud AI is your friend unless you want hypersensitive and hyper-private tasks. And we'll demonstrate the spectrum of privacy in another Pulse episode. We'll have it. This is Comfy UI here. It allows you to really make workflows on image. Video is going nuts though, so things change so quickly, might not be worth getting too deep in.
Absolutely. All right, everyone, that brings us to the end of our deep dive into LLM diffusion. I hope you enjoyed exploring these fascinating topics with us, from the basics of diffusion to its application in image models and large language models. And of course, we got to check out those awesome demos. Thank you so much for tuning in. And until next time, take care and keep exploring.
Hi, I'm Sam from Mind Model AI, and I want to automate your business.
Imagine a world where tasks are streamlined, errors are mitigated, and your team are able to focus on what truly matters. The rise of AI is happening faster than many anticipated, with more businesses every day recognizing its potential. From small businesses to large enterprises, AI isn't just an experiment anymore. It's becoming a core part of strategy. Let's find practical ways for your team to adopt it and drive meaningful change. So we build platforms and design smart automations to the specifics of your existing processes. This leads to accelerated operations, real-time insights, lower costs, growth in performance, and happier, more engaged team members. So what's our approach? We want to know what makes your business tick and find some real headaches to solve. We build everything in parallel to your existing approaches and keep them modular as to future-proof them to new advancements. This method ensures a smooth transition with little to no impact to your operations. How do we do it? So automation has been around for a while, but with new advancements in AI, a whole lot more is possible, with faster and better results. Every business is unique, and we can craft solutions that match it, almost perfectly. We also offer captivating in-person workshops on how to use AI in useful ways for anyone in your organization instantly. One question: are you ready for an economic slowdown? Addressing inefficiencies before they become critical can ensure your business remains strong and resilient. I want to empower your workforce and prepare your business for the future, making everyone's job easier and more effective. You may also be stuck in outdated systems. Unlike others, we can build custom protocols and interfaces around them to connect old systems into the cloud. Here's a quick example around automating a real estate rental business. Potential tenants choose their accommodation options with pricing calculations. Information is collected using text or vision, and corresponding deposits are detected and processed. An automated signing of the lease agreements are sent, signed, and the move-in is scheduled. AI caller agents, messaging systems, and real-time dashboards keeps everyone informed. All on its own and around the clock, 24/7, 365.
So let's explore the future of business and prompt potential together. Book a brainstorm today.